You'll notice the middle star looks a bit fuzzy. Take another look with a pair of binoculars, and you'll see it's not a star at all, but a fuzzy little smudge. A look at even greater magnification with a telescope will reveal a cloud with striations and details. This is the Great Nebula in Orion, a place where new stars are being born, a sort of stellar nursery, if you will, and as you can see, quite beautiful. Just below Orion's feet is one of my favorite constellations, Lepus, the bunny rabbit. He's got a head, a pair of ears, and a cute little bunny body. Our last two constellations for the night are Orion's dogs, Canis Major, the big dog, and Canis Minor, the little dog, which I figure must be a wiener dog because it's just two stars, though one of the stars is Procyon, the ninth brightest in the sky. Not to be outdone, Canis Major has the brightest star in the entire night sky, Sirius the Dog Star. The ancient Egyptians used to use the first sight of this star as a notice for the annual flood of the Nile River and for when to plant the crops. And that's it. There are other, smaller or fainter constellations out there, which I encourage you to look for, using a good book and maybe a pair of binoculars too. Speaking of good books, I cannot more highly recommend the book The Stars, A New Way to See Them, by the author H.A. Rey, who you may know as the same author who wrote the Curious George books. Rey was a scientist who wasn't satisfied with the way modern star charts were being drawn. The astroscientists were not interested in the characters and the objects and the stories behind the constellations, so for convenience they just connected the brighter stars into weird geometric shapes, slapped on their Greek names, many of which would mean nothing to the common person, and left it at that. That's all fine and well for them, but for us regular folks, we're more interested in the fun stuff. If you really want to learn the constellations, get Rey's book, which can be purchased from Amazon.com for about $12. I'd also recommend getting a pair of binoculars before getting a telescope. Binoculars are cheaper and easier to use, and there are many wonderful deep sky objects that can actually be best seen with just a pair of binoculars, and they're all noted in Rey's book. If you do want to get a telescope, ask us or research on the web how to make an informed purchase. Be warned, there are a lot of bad telescopes out there with cheap components and shaky, muddy, fuzzy views that will disappoint you every time. A good telescope will inspire you and your children to a lifetime of deep space exploration and an appreciation of science and nature in general. If you're interested in getting into the hobby of astronomy, joining a local astronomy club can be most helpful. Chabot is partnered with the EAS, the East Bay Astronomical Society, which has many activities and resources you'll find essential to help you get started in this amazing and beautiful study of our natural universe. Thanks for watching this video. If you like this content, be sure to click on the thumbs up button, subscribe to our channel, and hit the bell notification icon to find out when new content has been uploaded. This will really help our channel to grow, which would make us all very happy. And until we meet again, we'll see you in the future.
All right. Well, that was pretty good. Hey, I wanted to talk about a couple of things that was mentioned in the video. You heard the narrator talk about M44, which is also known as the Beehive Cluster. And he also talked about the Great Nebula in Orion, which has another M designation, M42. And if you talk to astronomers and let them wow you with their descriptions of all the things that are up there in the night sky, you will hear them frequently use that M designation, M5 and M13 and M44 and M42 and so forth. The M stands for Messier. Charles Messier was a French astronomer in the 18th century, latter part of the 18th century. And Charles Messier got the idea that he might be able to make a living by finding comets, undiscovered comets, and getting rich people to pay him to name the comets after them. So that was his scheme, and he spent a lot of time searching for comets. And the way he did it was to scan the sky with his telescope. Of course, in those days, his telescope wasn't as good as what we have today. And he would scan the sky looking for little fuzzy objects that didn't look like stars, but looked rather like just fuzzy blobs out there in space. And when he found one, he would then watch it for a period of time to see if it moved relative to the background stars. And if it moved, then there was a good chance he had found a comet. So that was his scheme. The problem he ran into is that as he scanned the sky, he would periodically run across faint fuzzy objects that didn't move. He'd watch them for a while and realize they weren't moving and they were something else other than a comet. So to avoid rediscovering the same faint fuzzy object over and over again, he got smart and made himself a list of all these faint fuzzy objects that he was seeing. And that list ended up having a little over 100 objects on it. And it became known as the Messier Catalog. Now today, we don't know of any comets that were named after Charles Messier, but the Messier Catalog is still in use. We still refer to it quite frequently. We've since added a couple of more objects to it. There are now 110 Messier objects. In fact, I'm going to share my screen here for a second, show you an image. There it is. There's all 110 Messier objects. And you can see there's a wide variety of different objects in the Messier catalog. Lots of what we call globular star clusters, these round blobs of stars. Of course, lots of galaxies and other kind of cloudy objects, some of which we call planetary nebulae. Some are just emission or reflection nebulae and so forth. And these are all faint fuzzy objects out there that he couldn't see very well with his telescope. But today, with much better telescopes, we can see them quite clearly. And so this is the Messier objects. And I wanted to let you know that tomorrow night, we're going to do something unusual here at Chabot. We are going to look for all 110 Messier objects in the Messier catalog. Each year, in the springtime, kind of the middle of March, it turns out that these objects, which are spread across the whole sky, but it just turns out that if you start looking as soon as you can after sunset, and if you're willing to stay up all night, you can actually view all 110 Messier objects. And astronomers today call that the Messier Marathon. And it's a big deal, especially for amateur astronomers, to at least once in a lifetime do a Messier Marathon. So we are going to be doing it tomorrow night. We are doing it as part of an international program that was set up by a couple of guys at a company called Unistellar. They make a very unusual type of telescope. And a couple of those guys are actually also members of the SETI Institute, the Search for Extraterrestrial Intelligence Institute down in San Jose, or I guess it's in Mountain View. So they have organized this international event, and observatories and amateur astronomers and people, schools, and so forth all around the world are going to participate in this, and we're all doing it during a very small time frame, basically about a 8 or 9 day period, depending on which institution is doing it, they pick the date that works best for them and attempt to do it all night long. So here at Chabot, we are going to do our Messier Marathon starting at 7:30 tomorrow night, Saturday, the 13th of March. And we are starting at 7:30, and if all goes well, we should be done by about 6 o'clock in the morning, Sunday morning. Now, interestingly, tomorrow night is also the night when we change the clocks. So we're starting at 7:30 p.m. Standard Time, and we're going to end at 6 o'clock a.m. Daylight Time. So we're going to lose an hour of sleep in this whole process, and we're going to stay up all night, so it doesn't matter. So that's our hope. Now, right now, the weather forecast is looking kind of iffy. There's a good chance that we're going to get at least most of the ones that we would be able to find before midnight. But after midnight, it looks like the clouds might start to move in. So we may not be able to get all 110, but we're going to do as many as we can. And we're going to do this virtually. So you'll be able to join us. Again, this is tomorrow night, starting at 7:30. We will put cameras on our big telescope, and we're going to put more than one camera on it because some of these things are large and the field of view of the main telescope is too small. So we'll put a camera on a smaller telescope mounted on the side of the large telescope, which will give us a wider field of view. And we will try to image and share those images with you of all of the Messier objects that we're able to find. Hopefully we'll get all 110, but I suspect we're going to get weathered out sometime after midnight. But I certainly invite you to join us. If you want to stay up all night, you're welcome to do so. If not, we will be recording it and it will be available later on. So hope you can join us for that. So what I'd like to do now is kind of open things up here for questions from the audience. I'm being assisted here by Lisa Hoover, who you saw a little bit earlier. And Lisa has been watching Facebook, and I think she's been watching YouTube, although I think we're having trouble with our YouTube connection tonight. So I know she's been watching Facebook, and she's going to come on here and pass on any questions that you have, any astronomical subjects that you want to talk about from anything that was covered in the video, anything you've heard recently on the news, whatever, go ahead and fire away. So Lisa, you see any questions?
Yes, and we're live on both platforms.
Oh, okay.
So we have a question here from a couple of folks. Can you see any of the Messier objects with binoculars?
Yes, quite a few of them actually. In fact, some of them you can even see naked eye. Now, one of the things that was covered in the video was M44, the beehive cluster. That's a really great binocular object. It looks actually best in looking at it with a pair of binoculars. But there are others. One that's also was covered tonight was the Pleiades star cluster, which is, I believe, called M45. And a Pleiades is visible to the naked eye, and it shows up very well in binoculars. The Orion Nebula, M42, also shows up pretty well in binoculars. So yes, there are quite a few Messier objects that can be seen easily with binoculars. And like I say, some of them can even be seen with the naked eye if you know right where to look. Later on in the night, there's a globular star cluster called M13. You can see that with a pair of binoculars. And if you're in a really, really good dark night sky location, you can actually see it with the naked eye as well. So yes, lots of things to see with binoculars, but telescopes help, although you don't need a big telescope. You can see most of them even with a small telescope.
Question from one of our viewers. What's the contingency plan for rain?
Well, what we are doing is collecting images, mostly Hubble Space Telescope images, but we're collecting images of as many of the Messier objects as we can. And if we can't observe with our telescope. We're going to share images of all these objects with you, talk about each one, how far away it is, what the object is, and so forth. And one way or the other, we're going to share at least some, if not all, of the Messier objects with you.
Great. Question from Chris wants to know, what's a good starter telescope?
Well, first of all, the first thing we recommend is you get a pair of binoculars. If you get a pair of binoculars and a nice constellation book, a book that shows, very simply the night sky, you can learn your way around quite well using a pair of binoculars. And like I said, there are a lot of cool things that you can see with binoculars. If you want to then go the next step and get yourself a telescope, what we normally recommend is a style of telescope called a Dobsonian telescope. And this is a very simple telescope with very good optics. So a typical Dobsonian telescope might be 6 inches in diameter or 8 inches in diameter. It's a reflecting telescope, so it uses mirrors instead of lenses. And it's mounted on a type of mount that's kind of like a lazy Susan. If you're familiar with a lazy Susan, it swivels around down low on the ground and also tips up and down. It's the type of mount we call an alto azimuth or altitude azimuth mount. It's not very sophisticated. You want to move it from one object to another, you move it by hand. It's not motorized or anything like that, but the optics are really good. And with a Dobsonian telescope, you can find a lot of those much fainter objects and actually view them. Because it doesn't have a motor, it won't track the objects. So you have to point the telescope at those objects yourself, learning where they are and learning your way around the sky again. And there are amateur astronomers who get a Dobsonian telescope and they decide never to get any other telescope. They're so happy with the Dobsonian. And the cool thing is they're relatively cheap. A 6-inch Dobsonian telescope can cost you as little as $300. 8-inch will cost you maybe another $100. You can get bigger ones, but really somewhere around 6 or 8 inches, especially for a beginner, that's just about right. Really opens up the sky. And, people always want to know, well, can I see the rings of Saturn? Yes, you can. Even a 6-inch Dobsonian telescope will show the rings quite well.
Nice. Another question. Can you elaborate on the potentially hazardous asteroid flying by on March 21st?
Sure. Don't worry about it. So there is a big asteroid. It's about, I think it's around 600 meters, 500 to 600 meters. And that's an updated size. Originally, we thought it was bigger, but just very recently, some new work was done on this asteroid, and we realized it's not quite as big as we thought it was. It's called 2001 FO32. And this is an asteroid that will pass somewhat close to the Earth. It's actually going to be farther away than the moon, so there is absolutely no danger to the Earth. But the thing that's cool about it is that because of its large size, it will be relatively easy to see in a telescope if you're in the right place. Unfortunately, we won't be in the right place. It's best viewed from the southern hemisphere, but it is a good size asteroid, and it's getting some publicity here. There are people who, they watch all the time to see what asteroids might be coming close to the Earth, and every time they see a big one, they like to talk it up a lot. And so I've seen quite a bit of news coverage about this. But I want to assure everybody there is no danger at all from this asteroid. It's interesting because of its size and the fact that we will be able to see it with the right telescope in the right location. But other than that, it's just another near-Earth asteroid. People might be interested to know that we actually get buzzed by asteroids quite a bit. I was looking at some data just the other day, and since January 1st of this year, there have been 22 near-Earth asteroids that have passed closer to the Earth than the moon. So the moon is about 240,000 miles away. These asteroids all came closer to the Earth than 240,000 miles. Now, 240,000 miles is actually a lot of distance. So it sounds dramatic, but it's actually not all that dramatic. But there are asteroids out there flying around all the time, and it's actually very rare for them to hit the Earth.
All right. We have a question about the, forgive me if I butcher this name again, I'm going to get it right one of these weeks. The Oumuamua project. Am I
Oumuamua.
close this time?
Oumuamua.
I'm going to write that down. That one.
Yeah.
One astronomer at Harvard suggested it could be alien.
Yeah.
But the cosmos
Yeah,
is
there's
full
already
of
been
sorts of strange objects.
Yeah, there's already been several papers written debunking that one astronomer's theories. Oumuamua was, I think it was 2017 when it was discovered. Somebody will correct me if I'm wrong, I'm sure. And it was a object that at first looked like it was just another comet from the Oort Cloud. The Oort Cloud is a region around our solar system. It's pretty far out from our solar system, and there are a lot of icy bodies out there. And every once in a while, one of them kicks loose from its orbit around the sun out in the Oort Cloud, and it comes in close to the sun, and we see it as a comet. So when this object was first spotted, it appeared to be just a comet, but then we realized it had an unusual orbit. A comet's orbit, a comet coming from the Oort cloud, has a very elongated elliptical orbit. It's highly elongated, and it's difficult to determine when you first observe its orbital characteristics that it's an elliptical orbit. But as we get more and more data, we realize that it is definitely an elliptical orbit. With Oumuamua, it turned out it did not have an elliptical orbit. It had what we call a hyperbolic orbit. And in a hyperbolic orbit, the object comes in towards the sun, whips around the sun, and instead of going back out like it would in an elliptical orbit, Oumuamua came in towards the sun, whipped around the sun, and then went back out in a different direction. And so we call that a hyperbolic orbit. And the only way it could be in a hyperbolic orbit is if it came from outside our solar system. So this got astronomers pretty excited. We knew that things like this happen because when new stellar systems form and they form planets and so on, it is inevitable that some of those planets and planetesimals and parts of planets and so on get ejected by the solar system during its early formation phases. So we knew that there were a lot of these sort of rogue objects flying around out in the galaxy. And so it was just inevitable that sooner or later one of them would come in and fly around the sun. So we knew this happened, but we never had actually seen it happen until Oumuamua. And so that got people pretty excited. But one of the things that was unusual about it is its shape. It turned out to be not potato shaped like your typical asteroid or comet. It turned out to be highly elongated, like a long cigar or something like that. And of course, that kind of got people interested. And how did it get that shape? And wouldn't that be the shape of a spacecraft from another solar system somewhere? And then it did something else that really got people interested. After it came in and went around the sun and on its way back out, it suddenly changed velocity, which it shouldn't have done. It should have followed normal orbital mechanics rules that says as it moved away from the sun, it gradually slowed down. And there would have been the only change in velocity was what you could predict based on the gravitational pull of the sun. Well, something happened. And that really got astronomers interested and, kind of jazzed up the idea that maybe this thing was artificial. Maybe it was a alien spacecraft of some kind. Well, it turns out we figured out why that was happening, and it had nothing to do with alien propulsion systems or anything like that. It was just because of the nature of this object. It had some outgassing going on, and that changed its velocity. Nevertheless, there are a few people out there who continue to hold on to the idea that this is potentially an alien object of some kind. And then going so far as to say this was, aliens surveying the solar system to check us out before they invade. That's all bunk. So, and like I say, there's, that article came out here not too long ago. Some astronomer who sort of argued that there was still evidence that it could be artificial. And within days, there were more articles coming out from other astronomers who pointed out all the flaws in that initial argument. So it's just a big rock came from another solar system somewhere, and it's on its way out, and we won't have to worry about it. All right.
That's good to know. Thanks, Bill. We have a question about back to the telescopes. Can you attach a camera easily to a Dobsonian?
You can. In the Dobsonian telescope, the eyepiece is on the side of the tube. So you have a long tube. There's a mirror at the bottom of the tube, and up at the top of the tube, the eyepiece is mounted on the side. The eyepiece then looks into the tube to a small mirror, which then reflects the image from the primary mirror to the eyepiece. You can mount a camera to that eyepiece holder position. You take the eyepiece out and you put the camera in its place using an adapter. And that's done quite often. The problem with a normal Dobsonian telescope is it's not tracking. So because of the rotation of the Earth, any object that you're looking at will slowly drift across the field of view. So you can only take very short images, half second at the most exposure. But a lot of those deep sky objects, if you want to photograph them, you need to make exposures that can be several minutes long. And because the Dobsonian telescope is not tracking, you would end up with just a streak across your image. So you can take pictures with a normal Dobsonian, but you have to understand those limitations. Amateur astronomers who decide to get into astrophotography, they buy a mount. They take the same telescope and they put it on a different kind of mount. And that is a tracking mount. It has a motor and they're often computerized, and they can track an object for long periods of time, and then you do long exposures. The telescope that we're going to use tomorrow night, it's not a Dobsonian telescope, but it does track just like what I'm talking about here, and that's going to enable us to take pictures of all these Messier objects, and some of those images will be 30 seconds or a minute long exposure.
All right. Our next question is there a lineup of Mercury, Jupiter, and Saturn this weekend?
There may be. I haven't checked into that. I've been so busy preparing for this Messier Marathon that I haven't really looked at that, but it's quite possible. I know that they're all sort of close together. Yeah, it's possible that that's going to happen. And, you go to a number of different websites and check that out. There's apps on your phone that you can use, like Sky Safari. There are planetarium programs that you can use, like Starry Night or Stellarium. Stellarium is a free program that you can do on your computer. They also have a website where they basically do the same thing on their website. So you check out any one of these and it will show you what the sky is going to look like at a given time. And that should tell you whether or not there's going to be a lineup. But just based on my recollection, yeah, I think sometime this weekend there's going to be a lineup of a few planets. That it'd be relatively close to the sun, but you should be able to see it.
Nice. What's the closest black hole we're aware of? A young scientist would like to know.
Probably Cygnus X1, which was coincidentally the first black hole that was ever confirmed. The constellation Cygnus is a summertime constellation, summer and fall. And the Cygnus X1 was an X-ray source. When it wasn't seen visually, it was seen because black holes often emit a lot of X-rays, and astronomers figured out that there was a source of X-rays up in the constellation Cygnus that had no visible star associated with it, and that turned out to be the first black hole. And that one we think is probably one of the closest black holes that we know about. I'm sure there are others that we don't know about, but Cygnus X1. So you might, if you want to find out more about it, just Google Cygnus, Cygnus, Cygnus X-1.
All right. Over to YouTube, we have a question. What causes comets to form and fall?
A comet is an icy body that originates on the outer part of our solar system. There are two what we call comet reservoirs in the solar system. One is called the Kuiper Belt. The Kuiper Belt is a region that's just beyond the planet Pluto, the planet Neptune. And it's a region that's sort of roughly parallel to what we call the ecliptic, which is the plane of the Earth's orbit. And these are all icy bodies that can be, very small, a few meters across. Many of them can be several hundred meters across or even several kilometers across. And they're like asteroids, except an asteroid is mostly rock, and these cometary bodies are mostly ice. So it's a big chunk of mostly ice with rock and gravel and sand and so on embedded within the ice. And these objects orbit around the sun. In the Kuiper Belt, they orbit all in the same direction as the Earth orbits around the sun. And like I say, they're all close to, although not right on, the ecliptic plane. Once in a while, one of these objects gets out of the Kuiper Belt for different reasons: gravitational interactions, collisions with other Kuiper Belt objects, a passing star. There's different reasons why it might happen. And this object then basically falls out of orbit and comes in towards the sun. And instead of being in a roughly circular or modestly elliptical orbit, it goes into a highly elliptical orbit, comes in, goes around the sun, and goes back out. When it's out in the Kuiper Belt, that icy body is not producing a tail or anything like that. It's just out there where it's nice and cold and quiet. As it comes in, as it gets closer to the sun's heat starts to warm up that ice, and eventually the ice does something called sublimation. Here on Earth, in our normal atmosphere and so on, if you take a chunk of ice and set it on the table and watch it, it first melts and becomes a liquid, and then if you wait long enough, it eventually evaporates and becomes a gas. In sublimation, we skip that liquid phase. So we go straight from solid ice to a gas. And that process is called sublimation. So what happens is, as this object comes in, gets closer to the sun's heat causes the ices in the comet body to start sublimating. As that happens, two things go on. First of all, the gas drifts away from the comet body and is captured, if you will, by the sun's solar wind, which blows this gas vapor away from the comet body, producing a long, pretty much straight tail that extends directly opposite direction from the sun. So if the comet is going this way and the sun's here, the tail is going to be on the opposite side. The other thing that happens is embedded in all that ice is gravel, sand, rock, and so forth. And as the ice sublimates, it releases all this solid matter, all these particles. And those particles then drift away from the comet body and form a second tail. And the two tails are often very easy to distinguish from each other because the gas tail will often flow straight back from the comet, whereas the particle tail will sort of curve a little bit. The particles are subject to orbital dynamics. So they actually drop into an orbit that's similar to the orbit of the comet, whereas the gas tail is mostly being influenced by the solar wind, which just blows it straight back away from the comet. So that's how a comet, or where comets come from and how they're formed. Now, I mentioned the Kuiper Belt. That's one comet reservoir. And like I say, it's a region out beyond Neptune, extends maybe 100, 150 times farther from the sun than the Earth. But there's another comet reservoir called the Oort Cloud. And the Oort Cloud is very different. The Oort Cloud completely surrounds the sun and the solar system. And objects in the Oort Cloud are much farther away. There are some objects in the Oort Cloud that are literally 1 light year away from the sun. And these objects also icy bodies, but they orbit in any direction they want to. They can go, in the same direction as the Earth. They can go in the opposite direction. They can be perpendicular to the Earth's orbit. They just go in whatever direction. And once in a while, those objects also can get knocked out of their orbits out in the Oort Cloud and come in towards the sun. They have very different orbits. The orbits take much longer. A typical Kuiper Belt object, a comet, will have an orbit maybe 100, 200 years, whereas a Oort Cloud comet will have an orbit that takes thousands of years. So but the same idea holds true. Once that Oort Cloud comet gets in close enough to the sun, it starts sublimating the ices, and you get the two tails and so forth. So, last year we had that comet called Neowise that was actually visible to the naked eye. That was an Oort Cloud comet. And so it came in once, we saw it, enjoyed it, but you have to hang around for a few thousand years if you want to see it again. All right?
Nice.
I see I have a new moniker. Yeah, I guess Stephanie's your daughter, Erica. Is that right? She's given me a new moniker, the Space Guy. So.
I like it. Question about tomorrow's event.
Right.
Is this the first time that you're holding the marathon? And what's your favorite object?
Well, this will be the first time that we have done a Messier Marathon here at Chabot, and it will be my first time doing a Messier Marathon. Now, tomorrow night, a couple people will be joining me. Richard Ozer, who is the president of the East Bay Astronomical Society, which is based here at Chabot, and John Curry, who is another Chabot volunteer. He's also a member of the East Bay Astronomical Society. I don't know about John, but I do know that Richard Ozer has done a couple previous Messier marathons, so it's not the first time for him, but it will be for me.
Nice.
And my favorite object, gosh, out of the Messier catalog, I have to say M42, the Great Orion Nebula, is my favorite. It's an easy object to find. It's got a lot of stuff going on, so it's pretty interesting to view with the telescope.
Awesome. Another question from YouTube. can you land a spacecraft on a gas giant, or would you just fly through?
You can't land on it. What you can do is orbit around a gas giant, and we have sent probes to I won't say land on it on a gas giant, but we have sent a spacecraft that basically crashed into gas giants on both Jupiter and Saturn. What happens is the spacecraft descends into the clouds of a gas giant, for example, Jupiter. The Galileo spacecraft back in the 1990s did this. And then for Saturn, the Cassini spacecraft back in 2015 did this. They descend in and penetrate the outer cloud layers. But once they get into the denser part of the clouds, they're getting buffeted. There's a lot of dynamical forces going on, and the spacecraft breaks up, and it continues on down to the point where it's under very high pressure, and of course it's got all its velocity, so the spacecraft breaks up. Technically, there is no solid surface, but we think that for Jupiter, there is a solid core deep down inside the planet, maybe only 1,000 kilometers or a couple thousand kilometers in diameter, and that core may be rocky or even metallic. So, if you get that far, yeah, I guess you can say you have something to stand on. However, if you get that far, you're also subject to extreme pressure, because that deep in the planet, you've got all that atmosphere piled on top of you, and it gets denser and denser as you go down. And so the pressure would be tremendous, and you would not survive, and neither would your spacecraft.
Wow. We have a question about space junk.
Okay.
How much is in orbit around the Earth?
Too much.
Does it present any hazards and for in and outgoing spacecraft? And is there any way to clean it all up?
Yeah, that's a loaded question. So yes, there is a lot of space junk. Every time we launch a spacecraft, we leave some junk floating around, either floating around the Earth or even floating around the sun in such a way that it periodically comes back and gets close to the Earth. In fact, one of the things we do here at Chabot, we are part of an international group of observatories that searches for and tracks near-Earth asteroids. And every once in a while, we end up searching for and tracking what turns out to be an old rocket body that had gone into orbit around the sun after it had been used up, and eventually that orbit brings it back around to the vicinity of the Earth, and we think it's an asteroid until we start analyzing it and realizing, no, it's an old rocket body. So there's a lot of space junk, and the space junk can be anything from a loose screw to whole chunks of spacecraft. There have been a couple of instances where two satellites crashed into each other, most of the time accidentally, a couple of times deliberately. And those collisions produced a lot of bits and pieces of the spacecraft that are now in orbit around the Earth, and lots of hardware left over, a few wrenches and other tools that astronauts accidentally dropped while they were working on the space station or in the space shuttle. And all this stuff is in orbit, and it has actually cluttered up the space around the Earth quite a bit. And there are a number of agencies, actually not a number, there's several agencies that keep track of this, and they're able to track most of the stuff down to about, say, an inch in size. And we do have to keep that in mind as we launch spacecraft and as we maneuver spacecraft around the Earth. Where are those objects? And if you pay close attention to what's going on with the space station, you'll find that every once in a while they do a little maneuver to avoid a known piece of space junk that will get too close to the space station. They've got basically a safety zone around the space station. And anytime it appears that a piece of space junk is going to get within that safety zone, they will maneuver the space station to avoid that piece of space junk. It is a problem. And like I say, they can't track it all. If you got something this big, they can probably track it. But if it's this big, they probably can't track it. And even though it's only very small, a loose screw that some astronaut dropped or that fell off of a spacecraft, that loose screw can do a lot of damage if it hits a spacecraft. Things are flying around in orbit around the Earth at 17,000 miles an hour. And if a screw hits a spacecraft at 17,000 miles an hour, it can punch a hole in the spacecraft. And so they have to design spacecraft with that in mind. The space station has some protection so that if it does encounter an object that hits it like that, a small object that punches a hole in it, they can withstand that collision. And but it is an issue, and it's getting worse because every time we launch something into space, there's a little bit more space junk that's floating around out there, even though the spacecraft itself, like, for example, the Perseverance rover that just went to Mars, to get into the long orbit they took it from the Earth to Mars, it had to be launched using a rocket, a couple of stages. And as that rocket lifted the Perseverance capsule inside what was called the aeroshell up into orbit, little bits and pieces flew all over the place, and some of that stuff stays in orbit, and it can be a problem. And, there have been proposals for cleaning it up. Nobody is actually doing it yet, but there have been a couple of proposals for cleaning it up. There's also been some proposals for mandating that if you launch a satellite into space, you have to do something to mitigate the space junk, for example, if you launch a satellite and it's only going to operate for 5 years, you don't just leave it up there. You do a controlled descent back into an ocean, basically crash it back to the Earth. Not everybody agrees on what the rules ought to be and how this all should be done. So no formal agreement has yet been signed by all parties, but it is an ongoing discussion.
All right, I think we're at the conclusion of our question and answer period. Those
Okay.
are really nice questions. They're always really fun.
Yeah.
We appreciate you all for watching. We do have some announcements. Don't forget, it's tomorrow, the Messier Marathon, 6:30 p.m. to after dawn, about 6:30 in the morning. Get your nap early. Same channel, Facebook and YouTube. And then on Tuesday, another exciting talk with our partner SETI. They will be here talking about citizen science astronomy for classrooms with Daniel Peluso. That's Tuesday at 7, and a brand new program launching on the 17th, Space News. So tune in all this week where we will be talking space.
You're going to be one of the reporters for Space News, right?
I'll be here with space weather.
All right.
Any other announcements, Gerald?
No, I think that'll do it. Bring coffee tomorrow night and join us, and we'll try to catch as many of those Messier objects as we can.
I'm looking forward to it. Orion is my favorite too. Well, thanks once and all. Don't forget,
vaccinated.
Get vaccinated. It's not too late to make a donation to help us continue bringing these programs direct to your homes every single week. Thanks so much for joining us. Good night.